its current flowing. But those words do not explain anything. They rename the mystery. Yes, electrons move, but why do they move? What pushes them? And why does that push create heat, light, sound, motion? To understand electricity, you must first abandon your intuition, because your intuition is built for contact. In everyday life, forces require touching. You push a door, you pull a rope, you lift a cup. Force seems inseparable from physical contact, except it isn't. Take a strip of plastic wrap, rub it between your hands, then hold it near the fine hairs on your arm. They rise. The plastic pulls on you through empty air. No wires, no batteries, no visible connection, just friction. What happened? When you rubbed the plastic, you transferred electrons from your skin onto the plastic. A tiny imbalance, perhaps one extra electron per trillion atoms. Insignificant, it seems, and yet that imbalance allows the plastic to exert a force across empty space. This is static electricity, but that phrase hides its importance. What you are witnessing is the electromagnetic force, one of the four fundamental forces of nature. The same force that holds atoms together, the same force that binds molecules, the same force that enables chemistry, biology, and life itself. We treat it like a party trick. It is one of the deepest facts of reality. Now consider something that challenges your intuition even more. Take two electrons and separate them by 1 centimeter. The electromagnetic force between them is roughly 1042 times stronger than the gravitational force between them. That is not a small difference. That is not even a large difference. That is an almost incomprehensible difference. Gravity is effectively irrelevant at the atomic scale. Electromagnetism dominates, and that creates a profound puzzle. If electromagnetic forces are so unimaginably strong, why is matter stable? Why does your body not explode from internal repulsion? Why does the Earth not tear itself apart? The answer lies in cancellation. Atoms contain positive charges, protons, concentrated in the nucleus. They also contain negative charges, electrons, distributed around that nucleus. Opposites attract, like charges repel. In ordinary matter, positive and negative charges are present in nearly perfect balance. The enormous attractive and repulsive forces cancel with astonishing precision. The forces are still there, enormous beyond comprehension, but they are balanced. And because they are so strong, even the tiniest imbalance produces noticeable effects. That plastic wrap experiment demonstrates this beautifully. A microscopic redistribution of charge creates a macroscopic force you can feel. Now take a mug in your hand. You believe you are touching it. You are not. What you feel as solid contact is electromagnetic repulsion between electrons in your hand and electrons in the mug. Your atoms never truly collide with the mug's atoms. They repel each other before direct overlap can occur. There is always a minuscule gap. The sensation of solidity is electromagnetic force preventing collapse. You have never truly touched anything in your life. Every push, every pressure, every resistance is electromagnetic interaction. Even the floor holding you up right now, even the chair beneath you. This realization alone should restructure how you see matter. Matter is mostly empty space. Solidity is a carefully balanced dance of electric forces. And electricity, the thing we casually use every day, is the deliberate manipulation of that force. But to understand how we manipulate it, we must move beyond static charge. We must examine motion. Because electricity is not simply charge, it is charge in motion. And motion changes everything. Up to this point, we've talked about charge, but electricity is not just charge. It is moving charge. And the moment charge moves, something new appears. Magnetism. For centuries, electricity and magnetism were thought to be separate phenomena. Static shocks were one thing, magnets attracting iron were another. Then, experiments revealed something astonishing. A moving electric charge creates a magnetic field, And a changing magnetic field creates an electric field. They are inseparable, two aspects of one unified force, electromagnetism. To understand electricity in your home, you must stop thinking in terms of particles flowing like water through a pipe. That analogy is comforting. It is also misleading. When you flip a light switch, the lamp turns on instantly. But the electrons inside the copper wire move incredibly slowly, typically millimeters per second. If electricity was simply electrons traveling from the power plant to your house, the delay would be enormous. Yet the light responds almost immediately. Why? Because what travels quickly is not the electrons. It is the electric field. Imagine a long tube filled with marbles touching each other. If you push one marble at one end, the marble at the other end moves almost instantly. Not because the first marble traveled the entire length, but because the push propagated through the system. In a wire, electrons already fill the entire conductor. When a voltage is applied, an electric field forms along the wire. That field exerts force on electrons everywhere simultaneously. The disturbance travels near the speed of light. The electrons themselves drift slowly, but the influence, the field, moves rapidly. Electricity is not a stream of particles racing through space. It is the behavior of a field interacting with charges. This is where intuition breaks down again. We tend to think of forces as objects acting on other objects, but in modern physics, forces are mediated by fields. A field exists at every point in space. The electromagnetic field fills the universe. Charged particles respond to the field at their location. When you flip a switch, you alter the configuration of the electromagnetic field in the circuit. That change propagates outward. And because the field interacts with charges, electrons begin to drift in response. This subtle distinction matters because it reveals that electricity is fundamentally about fields, not flowing substances. Now trace the process backward. At a power plant, a turbine spins. Perhaps it is driven by falling water, or expanding steam from heated water, or wind turning blades. That mechanical motion rotates coils of copper wire within magnetic fields. According to electromagnetic theory, when a conductor moves through a magnetic field, the magnetic field exerts force on the charges inside it. This force pushes electrons. That push establishes an electric field. The electric field drives current in the connected circuit. This is a generator. Motion becomes electricity. Run the process in reverse. Send electric current through a wire inside a magnetic field. The moving charges experience force. The wire moves. Electricity becomes motion. This is a motor. Generator and motor are mirror images. The same force, the same field, just reverse direction. This symmetry is not accidental. It was discovered mathematically by James Clerk Maxwell in the 19th century. Maxwell unified electricity and magnetism into a single theory described by 4 elegant equations. From those equations emerged something unexpected: electromagnetic waves. Light itself turned out to be a ripple in the electromagnetic field. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, all are oscillations of the same field. Your lamp does not simply heat a filament. It creates electromagnetic waves that travel through space. Those waves strike your retina. Electrons in your eye respond to the oscillating field. Chemical reactions begin. Signals travel through neurons. Your brain interprets light. Every step is electromagnetic interaction, not particles colliding like billiard balls. Fields interacting with charges. The deeper you go, the less mechanical the universe appears, the more it resembles a dynamic interplay of invisible fields. But something even more profound lies beneath this. Because electromagnetism does not merely explain electricity, it explains almost everything you physically feel. And that realization will reshape your understanding of reality itself. By now, electricity no longer looks ordinary. It is not a utility, not a convenience, not a fluid inside wires. It is the visible behavior of the electromagnetic field, one of the fundamental structures of the universe. And once you see that, something extraordinary becomes clear. Electromagnetism is not just responsible for light bulbs and motors. It constructs your entire sensory reality. Consider what you experience right now. You feel the floor beneath your feet. That sensation is electromagnetic repulsion between electrons in your body and electrons in the floor. You see the screen in front of you. Light, an electromagnetic wave, travels from the screen into your eyes. Oscillating fields cause electrons in your retina to move. Those movements trigger chemical reactions. Signals travel through neurons, themselves governed by electromagnetic interactions. You hear sound. Vibrations in air move your eardrum. Those mechanical vibrations are resisted and transmitted by electromagnetic forces between atoms. The signals inside your auditory nerves are electric impulses, tiny shifts in voltage across cell membranes. Touch, sight, hearing, chemistry, biology, electromagnetism. Even the chemical bonds that hold molecules together are electromagnetic interactions between charged particles. When atoms share electrons to form molecules, they are balancing electric forces. When DNA replicates, when proteins fold, when neurons fire, it is electromagnetism at work. The so-called mechanical world is built from electromagnetic foundations, and here is the deeper philosophical shift. You cannot explain electromagnetism in terms of something simpler. You cannot say it is like a spring or like a rope. Springs and ropes are themselves consequences of electromagnetic interactions between atoms. Electromagnetism is fundamental. It is one of the basic rules of the universe. Physics identifies four fundamental forces: gravity, electromagnetism, the strong nuclear force, the weak nuclear force. Gravity shapes the large-scale structure of the cosmos. The strong force binds atomic nuclei. The weak force governs radioactive decay. But electromagnetism is the force of everyday life. It shapes matter at the atomic scale. It determines chemistry. It governs light. It enables biology. Without electromagnetism, atoms would not form stable molecules. Chemistry would not exist. Life would not emerge. And yet its nature defies common intuition. It acts across space. It is mediated by fields. In modern quantum theory, it is described through the exchange of particles called photons, quanta of the electromagnetic field. These photons are not tiny billiard balls. They are excitations of a field that permeates all space. In quantum electrodynamics, the most precise theory ever constructed in physics, interactions between charged particles are described as probabilities of field excitations. The equations predict experimental outcomes to astonishing precision, better than 1 part in a trillion. And yet, conceptually, they challenge classical intuition. The vacuum is not empty, it seethes with fluctuating fields. Particles are not solid objects. They are localized excitations of underlying fields. Electricity, then, is not merely electrons moving. It is the orchestration of field interactions at macroscopic scales. When you flip a switch, you are altering the electromagnetic field configuration in a circuit. That configuration guides the motion of charges. Those charges transfer energy through the field. Energy flows not simply inside the copper wire, but in the space around it. This is another subtle truth. According to electromagnetic theory, energy in a circuit flows primarily through the surrounding field, not through the metal itself. The wire guides the field. The field carries the energy. Electricity is fundamentally about fields in space. Now step back and consider what humanity accomplished. 2 centuries ago, electricity was a curiosity. Static shocks, lightning, sparks. Then came systematic experimentation, careful measurements, the realization that electricity and magnetism are unified. From that understanding emerged generators, motors, telegraphs, radio, television, computers, modern civilization. We learned to manipulate a fundamental force of nature. We learned to convert mechanical motion into field oscillations, to transmit those oscillations across continents, to encode information into electromagnetic waves, to build networks of billions of switches, transistors, each controlling tiny electric fields. Your phone operates by guiding electrons through microscopic channels using electric fields. The internet functions through electromagnetic signals propagating across cables and through space. Satellites orbit Earth, transmitting microwave radiation, everything digital, everything connected, electromagnetic fields interacting with matter. Electricity is not mundane. It is the triumph of understanding invisible forces. It is proof that the human mind can grasp the underlying structure of nature and bend it to purpose. But beyond technology lies something even more profound, the realization that reality itself is not made of solid objects colliding in empty space. It is structured by fields. Fields that extend everywhere, fields that determine how particles interact, fields that create the illusion of solidity. Contact is not contact. Solidity is balanced repulsion. Light is oscillation of a field. Electric current is guided charge responding to field gradients. The world appears mechanical, but at its core, it is electromagnetic. And the next time you flip a switch, consider what you are doing. You are not merely activating a device. You are altering a field that permeates space. You are commanding electrons to respond. You are converting motion into waves and waves back into motion. You are participating in one of the deepest processes in nature. Electricity is not just utility. It is a window into the architecture of the universe, and the fact that we understand it, even partially, may be one of humanity's greatest achievements. Not comfort, not familiarity, but truth.